Okay, everyone. So today let's work on composing functions. So this is a review, although I know it's been a bit of time since the last time we did this. So let's think for a second. You know that this one's a function and this one's a function. And you could add them, you could subtract them, you could multiply them, you could divide them. Those are not different than the polynomial operations, okay? So when we compose, that means we're putting a function into a function. So we're putting things inside each other, okay? So when you think of this problem, it gives us f of x equals negative 2x minus 5 and g of x equals x plus 2. So what we're going to say is g is inside that f of x. So when I start writing my f of x, I'm going to write it out like this. F of, instead of writing x, I'm going to leave a blank, equals negative 2. Instead of writing x, I'm going to leave a blank, minus 5. Okay? And in that blank, we're going to put our g of x function. So again, g of x goes here, okay? So that's exactly what we had right there, which basically means I took this x in this function and replaced it with g of x. So this is negative 2 of g of x minus 5. However, g of x just represents x plus 2. So really, it's f of x plus 2. So it'll be negative 2 of x plus 2 minus 5. Okay? And what we'll do here is distribute the negative 2. Okay? So negative 2 times x is negative 2x. Negative 2 times positive 2 is negative 4. And bring down my minus 5. Okay? Combine like terms, so I get negative 2x minus 9. And that's the answer to the problem. Okay, if you want to be really fancy, you can write f of g of x equals that. So that is our full composition. Okay, that's a little low, sorry. There we go. Okay, so you can see we just combine like terms. One way you may see it written, I think, on Delta Math is this problem could be written f o g x like that. That means of. Okay, it's the same thing as the parentheses, f of g of x. Okay, the key is remembering which one to plug in. Okay, so you can see that g is on the inside, so we're going to plug that one into the other one. Okay, so let's look at these. Now this one on example 2 I've done on purpose. Okay, should not have done that. Should not have done that. It's gonna fall. Okay, so I have h of n is 3n squared plus 5 and 2n minus 3. Now every time I see squared, I'm going to highlight it and be like, okay, this may or may not make things complicated. I'm not sure yet. Okay, so first one here, we've got h of g of n. So h is on the outside, we're plugging g in. So instead of writing h of g of n, instead of writing n, I'm going to write in parentheses. Make sure to square it, plus 5. Okay. I think that does work. Just have to hold. Okay. So, inside this parentheses, I'm going to put the g function, which is 2n minus 3. Alright? So, all I've done is taken the n and replaced it with g. Okay? So, take the n, replace it with g, and so what I'm going to do here is do the math. Now, when you have this one, again, remember that's squared. That squared matters right now because it's outside of my parentheses. Outside the parentheses mean I need to take this 2n minus 3, and squaring means 2n minus 3. So I am basically multiplying those two out. Okay? That is the ugliest square in the world. Nothing changes my inability to draw. Alright. So I will then have my 2n minus 3 times my 2. Oh my god, squares. Squares. So I'll take these like this. I'm going to do it kind of small. Right? 2n times 2n is 4n squared. minus 6n, minus 6n, plus 9. So really, I have 3 times 4n squared minus 12n plus 9, okay, plus 5. So all that orange bit is just my multiplication for the squared portion, okay? Okay, so that only happens when you're replacing the function for the n squared. It's not very common, but you do have to pay attention and look out for it, okay? So when that happens, we end up having to duplicate it, multiply it, write it out, and now we can distribute that 3. You always have to distribute the 3 afterwards, okay? Because you have to multiply it and then distribute, okay? So we'll have 12n squared minus 12n, oh no, 12 times 3 is 36n plus 27 plus 5. So that last step, which I think y'all are going to be able to see, okay, is that my h of g of n is 12n squared minus 36n plus 32. That's as tough as it gets, okay, so it's not that bad, but let's look at the case. What if we flipped it around the other way? What if instead of plugging g into h, we plug h into g? Now this still has that squared, but okay, it's all about location. Okay, my g function is 2 blank minus 3. Fit it in there. And in that blank, I will put 3n squared plus 5. Now the squared is not going to cause the same difficulty we had here because the squared is inside the parentheses. See how it's outside here, inside here? So if it's inside, all we have to do is distribute and get 2 times 3, which is 6n squared plus 10 minus 3. So g of h of n is 6n squared plus 7. Okay, so it's all about the location of that squared, all about location. And you can tell it also matters what order. If I plug g into h, I get this answer. But if I plug h into g, I get this answer. So they're not the same. But they're not math you don't know. We have done this before. If you do need help, just let me know.